This study addresses the issue of the reduced application of wood as a predominant structural material in medium-rise buildings in Chile, especially because Chile is a good producer country. The final objective is to build, analyze, and test a prototype of a fully equipped housing unit being developed by Team Chile of the Universidad Técnica Federico Santa Maria to compete at Solar Decathlon USA 2020 competition. With the correct execution of this project, it is expected not only to demonstrate an innovative, efficient, and sustainable way to conceive a structural system, but also to promote and disseminate in Chile the use of timber as construction and structural building material, robot-assisted, and industrialized with innovative technologies. The low and medium-rise wood-based buildings is new in Chile. We have the opportunity to prove that there is a market for it, based in the fast construction, industrialized production, cost-effective, and sustainability commitment. Besides, adding opportunities to innovate on the Chilean housing industry sector. The good tradition in building in Chile is almost lost. It was typically developed by the wool and mine industries all along the country, inherited and brought by European immigrants that came around the beginning of past century. For example, the balloon frame structure and derived typologies were brought by British and Americans to Valparaiso and Iquique, while the Nordic tradition was brought to the southern cities of Chile. By analyzing this type of timber structures, it can be inferred that the section of their stud and the structural use of them defines the types of wooden frames. Then, for this research, only the massive frames or large studs will be considered as the primary structure, and light frames such as the platform frame as the design basis for the new structural system. The definition of the construction system to be developed for this research is defined in relation to the revised precedents. Innovation is addressed through flexibility and adaptability of home spaces based on the life cycle of families. The metamorphosis building is defined with an orthogonal structural system with a ground level of reinforced concrete to isolate the wooden structure. The two systems are connected through seismic isolators to separate the movements of the two structural systems, maintaining the common load transmission lines. The post and beam construction system is robot machine with timber joinery fixed with a steel pens, modular every 2 stories and assembled by a platform system between the third and fourth floor. Finally, the primary structure is completed with CLT slabs, precast, and dimensioned in medium sections for horizontal closing of the laminated timber framework. The wooden structure is made of blue laminated posts and beams frame of 15 by 28 meters engraved in a mesh that allow the special operations and variations. It is industrially manufactured and assembled through parametric design by robot-assisted carpentry. Home spaces are distributed according to operations with the greatest possible flexibility. Humid zones, facilities, and general circulation are kept fixed on the vertical volumetric bands. The prototype for Solar Decathlon 2020 USA is a 2-story high housing unit of the Metamorphosis building located at the edge of it. The structure was made of certified Douglas fir wood, provided by a local sawmill from southern Chile. Then, the dimensions needed to be adjusted. For the shorter beams, 185 by 185 millimeters, and 185 by 360 for the longer posts and beams. The total amount of good use was 11.85 cubic meters. This redesign produced new technical details and structural calculations that modified the load lines and changed the load directions of the posts and beams, inverting the load lines of the original frames. For the robot machine process, a prefabrication of 24 tenon in 12 beams and 24 mortise in 8 posts. These junctions build up for primary structure transversal frame. After the robot machine process was done, a comparison analysis of the prefabrication and materials of the structure of Casa Feni 2.0 prototype with other construction materials was carried out, comparing and evaluating the life cycle and span of the prototype.